Here we're going to verify an identity where we need to combine fractions. So here we want to show that sine of x plus cosine of x over sine of x minus cosine of x minus sine of x over cosine of x is equal to secant of x cosecant of x. Okay. Now, obviously, the left-hand side is more complicated here. So sine of x plus cosine of x over sine of x minus cosine of x minus sine of x over cosine of x. Now, what we need to do here is make a common denominator, make one fraction. So we're going to multiply the first fraction by cosine of x over cosine of x, because our common denominator is going to be sine of x cosine of x. So we need to multiply this, the numerator from the first fraction, by cosine of x. So cosine of x, and we'll distribute, times sine of x plus cosine of x. And we need to multiply the second one by sine of x. Okay, so if we FOIL those out, we're going to have cosine of x sine of x plus cosine squared of x minus sine of x cosine of x, which we can write as cosine of x sine of x. And a minus sign times a minus sign will be plus sine squared of x, all over sine of x cosine of x. Okay. Well, now we see that this cancels out with this. So we have we have cosine squared of x plus sine squared of x over sine of x cosine of x. Well, cosine squared of x plus sine squared of x is the same as sine squared of x plus cosine squared of x, since you can, since addition is commutative. And so we can say that that's equal to 1. So this is 1 over sine of x cosine of x. Now, when you're multiplying in a denominator, you can rewrite this as 1 over sine of x times 1 over cosine of x, because then if you just multiplied across, you would get what we started with. And 1 over sine of x is equal to cosecant of x, and 1 over cosine is equal to secant. In multiplication, we can also switch the order, so we can write it exactly how we started. Secant of x, cosecant of x.